So differentiating implicitly, I just differentiate normally, but then every time I differentiate y, I need to apply chain rule. So here I have a product of 3x times y. So I'm going to differentiate the x first, but then I have to use product rule. So I ended up with 3x, and differentiating the y, I get y prime. Okay, so that represents the product rule of the first part. Minus, I just differentiate the x normally, that's okay. You can stop there. Here I differentiate the outside function squared, but there's a y embedded, so I have to apply chain rule. Okay, so there's my implicit derivative. Now what is implied is I really should solve for y prime. So I'm going to group together my y prime terms. So there's my y prime, and I get 2y, y prime, and then on the side of the equation, I'm going to put the 4x, and I'm going to subtract the 3y. Okay, so then factoring out the y prime allows me to isolate the y prime value, so I end up with 3x minus 2y as my factor when I factor out the y prime. So that y prime here and here gets factored out here. Okay, so I'm left behind with these two terms. That's what's left in here. And so I have 4x minus 3y, and then solving for my y prime is 4x minus 3y over 3x minus 2y. And so this is my derivative. Now this is an implicit derivative, meaning I need to have the x and y to be able to calculate slope. Taking a look at b, I'm going to differentiate the e function first. So it stays the same. But because it's an embedded function, I have to apply chain rule. When I apply chain rule, I have to apply product rule. So I get the derivative of x times y plus x times the derivative of y. That's going to give me my y prime here. Plus, I'm going to differentiate the outside function, sine. So sine becomes cos xy. But because there's an xy embedded, I need to apply chain rule again. So I get 1 times y plus x times y prime. Okay, so it's going to look exactly the same as the first one. Okay, this first chain piece. And that's equal to the derivative of x is 1. So again, what's implied is I need to group together my y prime terms. So I'm going to end up with y prime e to the xy. And that I've got a plus. There's a cos xy. Oops, I forgot my x in here. I'm just going to move my x term here, and then I have e to the xy, and then plus, I've got my y prime, and I have x cosine xy. That x I could factor out as well, but I'm going to keep that in there because I want to isolate my y prime. Everything else goes to the other side, so I end up with minus y times e to the xy. Okay, so this term here and that term there go together to generate that term. And then I also have this term without a y prime together with that. I'm going to end up with minus, so it goes on the other side, y cosine of xy. Okay, so that's where that term came from. Okay, so then I'm going to factor my y prime out. So y prime, and this becomes x e to the xy plus x cos to the xy. Again, we can see that there's a common factor of x in there. If we need to, we can always factor that out. I'm just going to leave that unfactored for now. And then solving for y prime, I end up with y prime is equal to 1 minus y e to the xy minus y cosine of xy. And in the denominator of this expression, I'm going to end up with x e to the xy plus x cosine of xy. And there are no common factors, so I can't really cancel anything out here. So this is my final implicit derivative.